Okay guys, we're going to revisit a concept that you had learned in Algebra 2 regarding reference angles. You'll often see me designate a reference angle as the theta with a little REF beside it. So what is a reference angle? Well, it's a positive, non-obtuse angle formed from the terminal side and the closest part of the x-axis. Now, I know that actually has a lot of words going on in it, so I'm going to show you with a picture here what I mean. And I'm actually going to start here. Quadrant 1's the easiest. We'll come to that next. Let's look at quadrant 2. What I have right here is an angle, 94 degrees, so it's barely in quadrant 2, but it is in there. And its reference angle would be the terminal side of this angle, so it's this side, and the closest part of the x-axis, which would be this part right here. So basically I'm asking you, how big is that angle? So I'm looking for this angle right here. Now, when you're in quadrant 2, you do the same thing every time. Whether it's 94 degrees or 189 degrees, if it's in quadrant 2, so it's somewhere over here, what you do is you take 180 degrees and you subtract the given angle. That gives you the reference angle. So for this example, that was 180 degrees minus 94 degrees, which is going to give you 76 degrees. Oh, 86 degrees. That is our reference angle. Now, right now you probably don't understand maybe why that matters so much, but it will. It definitely will be important. If we were doing this in radians, instead of doing 180 minus theta, you would do pi minus theta. I think it makes sense. You know that the horizontal is 180 degrees, and so you take away this 94 degree part and you're left with this part right here. Now, back to quadrant 1. I didn't give you a picture because if you have an angle that's in quadrant 1, the given angle equals the reference angle. So I'll draw a quick picture. If I have an angle measure like, let's say theta equals 80 degrees, well, here's the terminal side, so we take the terminal side and the closest part of the x-axis. Oh, that's just the angle that we just drew, so it's the same thing. When stuff is in quadrant 1, life is really easy. The other quadrants are a little more complicated. Alright, looking at quadrant 3, I have an angle measure here of 245 degrees. Now, what we do to find the reference angles, we take the terminal side, which is this guy right here, and the closest part of the x-axis, which is this guy. And we're basically asking ourselves, okay, well, how big is just this part of the angle? And so basically, I want to take away this whole half circle up here. So to do that, you take your angle, theta, and you subtract 180 degrees. So in this case, we'd be taking 245 degrees, and we subtract 180, which is going to give me a reference angle of 65 degrees. Okay? Again, that's non-obtuse, it's positive, it's formed with the terminal side and the closest part of the x-axis. Now, if you had an angle in radians, instead of doing theta minus 180, you'd be doing theta minus pi, because 180 degrees is pi radians. It's the same thing. And then in quadrant 4, I have an example here. It's 290 degrees. putting us in quadrant 4. Our reference angle would be the terminal side here and the closest part of the x-axis right here. So this part is my reference angle. And to find that, you know, it looks like I sort of, with this angle and the reference angle, I have 360 degrees. But I don't want 360 degrees. I want to take away a major portion of that. So what I do is I take 360 degrees and I subtract the given angle. So on this example, we would take 360 minus 290, and that would give me a reference angle of 70 degrees. If you were in radians, instead of using 360, you would use 2 pi. This part. Okay, now, on the back, what I want you to do is practice finding reference angles. Now, a couple things here. I have some weird mistakes, like 7 pi over 4. I don't know why that was repeated there, so cross that out. And then down here, 11 pi over 6 is repeated twice. But what I recommend that you do on each one of these is you draw a picture, just a quick picture to see where the angle is, and then think about how to find the reference angle. I'm not going to go through each and every one of these on the video. What you're going to do is try these right now on your own, and then we're going to check them tomorrow in class.